Combat robots are essentially dangerous RC cars. My first exposure was the BattleBots TV show while flicking through channels, but it wasn't until around the end of 2023 when I realized that these robots could be much smaller and cheaper, easy enough for anyone to start out with. My tipping point was seeing this video of an American Antweight cheesecake, which apparently everyone has seen. Combat robots are divided into weight classes like boxing. BattleBots fight heavyweights, but over here in Australia we have three common classes. 30 pound or 13.6 kilo featherweights, 1.36 kilo beetle weights, and Antweights, which weigh in at just 150 grams. It was pretty easy to find a club near me that fought regularly, and so I began my research. Before I got too invested in this though, it would probably be a good idea to attend an event, both to get a feel for things and whether I actually like this, but also to meet and talk to people who would also give me advice on what components I should look for and whatever else. Fortunately, this event held a buy, sell and swap, where I was gifted some filament, and Titanium Joe very nicely gifted me some pieces of grade 5 titanium from some of his retired featherweights. Okay, now to the design. Broadly, there seem to be two branches of robots, big weapons and tough skins. Getting into a bit more detail, different types of weapons begin to appear, like vertical spinners, beater bars, horizontal spinners and so on, and those simple thick-skinned bricks gain actuators to manipulate opponents and become less passive. Obviously, flashy big hits appealed to me, and given I'd never built a robot before, the bigger I could make the stick, the more I could use that as a crutch to hide my inexperienced driving. Vertical spinners seemed complex to drive and required more skill in lining up with opponents, so I favoured horizontals, which had a large sweeping range. A bit more research led me to mid-cutters like Tombstone and Cheesecake. It would be fair to say that I'm basically making an evolution of the design in this tutorial by Teen Panic. Getting all the components and their weights into a spreadsheet, I could figure out how much weight I actually had to play with for chassis and weapon. Before I could start with some CAD, some design specifications need to be set out. The robot had to be able to drive upside down, since I didn't want to waste weight on a self-righting mechanism, and being unable to move is fatal. An extension of this, being stuck on a flat face and unable to get down, was another path to quick losses that really could be easily avoided. A third failure mode I'd noticed was wheels being torn off of robots, resulting in a countout. Finally, regarding the actual weapon itself, bars are light and simple, but often have trouble transferring energy at high RPMs. Discs store high energy, but are heavy. Single-tooth bars were slightly heavier than the simple rectangle, but allowed for twice the bite or engagement of the weapon. This was inspired by Cheesecake and seemed a good way to go. I would also pour as much weight as I reasonably could into the weapon to increase my reach. Having some experience with 3D printing and CAD, I modeled everything in Fusion 360 in a rough hierarchy. Any known components were positioned in space, followed by sketches of other dimensions like weapon diameter. After just a few wrong turns, like a 120mm weapon, I was able to come up with this design, which features a 100mm single-tooth weapon directly mounted to an 1806 motor, carbon fiber weapon mounts for lightweight rigidity, and a printed TPU body to absorb energy of impacts. Assuming Fusion's mass projections for the weapon and carbon fiber panels were on point, I would be just underweight. The robot was given the optimistic title of Yellow and Dangerous, as it was to be printed in yellow filament and would hopefully be quite dangerous. With the design ready, parts were ordered, and my attention turned to other things while I waited on delivery. One such thing was the need for a test box to safely test the bot before competition. The chassis was printed and weighed, components were soldered, Just before getting the remaining parts machined, my more accurate jeweler's scales arrived and indicated that Prussia Slicer had overestimated the chassis by almost 10 grams. I hadn't noticed this beforehand, as my prior set of inaccurate kitchen scales had a tendency to increase the reading by a gram roughly every second or so. Armed with this extra 10 grams to play with, I made the trek down to Wollongong to James's house to machine the last few parts. James, who you may know from Broken Link Robotics, is the event organizer for WRC and was a consistent source of advice and help throughout making this. He again helped me out by machining the carbon fiber panels and the weapon. final design came out to 147 grams, so comfortably under the 150 gram limit. After some tests in the test box, drive issues were identified and mostly fixed. Also, the weapon left gashes of up to 6 mils deep in the MDF, which was very encouraging. I would say the next video will be a fight report after I compete in early February, but that is quite a while ago now, so the next video will be a fight report, but I have already competed with this robot twice. I have also made a Mark II and have competed with that twice, so there should be some videos, soon, I guess. Again, go check out James at Broken Link Robotics. His videos are really good, and I would only have half of a robot without his help. Component lists and links to various things I found helpful will be in the description. You've got the ability to subscribe if you want to see that, I guess, if that course of action appeals to you. Bye.
In 3, 2, 1, fight! Whoa!